Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter Introduction to Atom. So basic concepts related to atom we are going to see in this chapter. In this session, let us see the introduction part from this. Everything around us is matter, isn't it? In the matter chapter we might have studied that everything around is made up of matter. The substances which we see in our surroundings, all there consists of certain particles which together considered as matter. Matter is made up of tiny particles called molecules. So every matter is made up of these smallest particles which we call as molecules, which can be broken down into still smaller particles which we call as atoms. So the name atom was based upon the Greek word atomos, which means indivisible. So we can finalize this. Every matter is made up of tiny particles called molecules. Say suppose this piece of chalk if we consider as a matter. What are the basic properties to be considered as a matter to have? One it should have certain mass and it should occupy certain place or space, then it is said to be a matter. If you see this piece of chalk, it is a matter, isn't it? Because it is having some mass and it is occupying some space. Now, as it is being a matter, it is made up of tiny particles called molecules. To understand that, if you take a piece of chalk and you break it into small pieces, and if you continue breaking that into smaller pieces, at certain time we are going to get the smallest particle of the chalk which we cannot break down into simpler particles by physical means. That the simplest particle of that matter is said to be molecule. So every matter is made up of molecules like this. These molecules are made up of still smaller particles, which we call them as atoms. So in every matter, the smallest particles are atoms. Actually, the meaning of this word atom itself is indivisible. So in every matter, there are smallest particles which cannot be broken down further. Those particles are called atoms. Okay, here everything like chalk piece, they are made up of molecules. These molecules are made up of different kinds of atoms. These atoms are indivisible. They cannot be broken down into still smaller particles. It was the earlier concept about the atom. The structure of matter has been under study from as early as the 4th century BC. Aristotle, a Greek philosopher, believed that matter could be divided into simpler particles. Not only Aristotle, other philosophers like Leucippus, Democritus, Epicurus of the 6th century also believed the subdivision of matter within atoms. So these all scientists and philosophers, they believed in the earlier times itself as matter can be divided into simpler particles, which we call them as atoms. So every matter can be divided into simpler particles, which we call them as atoms. So in this way, every matter can be divided into simpler substances, which we say as molecules. These molecules are made up of still smaller particles called atoms. So these all conclude that every matter is made up of small particles called atoms. So atoms are the building blocks of every matter. Now let us see the electrical nature of this matter. The electrical nature of matter was known in around 600 BC itself, when William Gilbert observed production of weak electricity by rubbing materials such as glass rod with a silk cloth. So he observed that the production of weak electricity when a glass rod is rubbed with silk cloth. So in that way, the electrical nature of matter was observed in the 600 BC itself. Not only that, by combing of dry hair also we observe certain weak electrostatic forces will be created. So the first important and experimental evidence of electrical nature of matter was established by Michael Faraday. in 1833. He showed that the flow of electricity is due to the flow of charged particles. So for the first time, he observed that the flow of electrical charge, and this is due to the flow of certain charged particles inside the matter. That was found by Michael Faraday in 1833. The term electron was suggested by G.J. Stoney for unit charge on a monovalent negative ion. So, after the finding of these charged particles inside the matter, the smallest charge or the smallest unit of charge was named as electron by the scientist G.J. Stoney, and the existence of electrons was later proved by J. Thomson. Okay, the existence of electrons was proved, and the electrons were discovered by J. Thomson. Let us see some ancient views of these scientists about the atom. The view of Maharshi Khanna. So the Indian philosopher Maharshi Khanna came forward with the following idea. In the 6th century BC itself, he proposed about this idea of atom. He told that matter is not continuous and made up of tiny particles called anus. These anus are made up of still smaller particles called paramanus. This paramanu represents the ultimate particle of every matter. Okay, he given in Sanskrit that every padartha is made up of small particles called anus. These anus are composite of still smaller particles called paramanus. Here, padartha represents matter, and anus represent molecules, and paramanu represents the atom. So here, the paramanu represents the ultimate particle of every matter, that is an atom. So in this way, in 6th century BC itself, Maharshi Khanna proposed about this atom as the smallest particle of every matter. Khanna further said that two or more paramanus combine together bigger molecules. So he proposed about the formation of molecules also. He considered that two or more paramanus of matter, they combine together to form bigger particles, which we are calling nowadays as molecules. And one more proposal, that is by Democritus. The Greek philosopher Democritus also came up with the similar idea about the atoms. He thought that on dividing a piece of substance, one would ultimately get a particle that could not be divided further. They gave the name atoms for this, the smallest particle of that matter, which means the indivisible. So Democritus also proposed the same similar idea. That is, every matter, if it is divided into small pieces, one would ultimately get a smallest particle of that matter which cannot be divided further. For that smallest particle of that matter, he named as atomos. It is one of the Greek words which means the indivisible. Okay. Next, Dalton's proposal. John Dalton. Chemist John Dalton was born in September 6th in England. During his early career, he identified the hereditary nature of red-green color blindness. In 1803, he revealed the concept of Dalton's law of partial pressures. So he given this law of Dalton's law of partial pressures about the gases. He was the first scientist to explain the behavior of atoms in terms of measurement of weight. So he was the first scientist who gave the explanation about the behavior of atoms in terms of their masses in measurement of weight. He proposed that matter is made up of very small indivisible particles. He called these individual particles as atoms, which means indivisible. He carried out several experiments on how elements combine and put forth his inferences in what is known as Dalton's atomic theory. So, based upon his several experiments, he proposed certain postulates. It came familiar with the name Dalton's atomic theory. The theories of Khanna as well as Democritus remained forgotten for more than 2000 years. But when experimental chemistry developed, it became necessary to explain the observed facts. In this connection, that means to explain the observed facts about the structure of atom and even about the nature of matter, the composition of matter. In 1808, John Dalton put forward his atomic theory. Now, let us see the important postulates from this Dalton's atomic theory. One among them is matter consists of small indivisible particles called as atoms. So, as studied in the earlier concepts about the atom, in the Dalton's atomic theory also, it was proposed that every matter consists of small indivisible particles, which we call them as atoms. These atoms can neither be created nor be destroyed. So he concluded that atoms are the smallest particles of every matter. These cannot be broken down into smaller pieces and even they cannot be created also. It means atoms neither be created nor be destroyed. That's one of the postulates. Another point is atoms of same element are similar in all respects. In all respects, in the sense, in the meaning of properties. If you consider at two atoms of same element, those atoms both will be having all the properties in common, like mass and other properties. These all will be same for the atoms of an element. Atoms of the same element are similar in all respects. Conversely, atoms of different elements are different in all respects. Okay, in this way, atoms of one element are having all properties same, and atoms of different elements are having all the properties different. This is one of the points proposed by John Dalton. Another point is atoms combine in small whole numbers to form compound atoms. These compound atoms nowadays called as molecules. Means he told that atoms of same element or different elements, they may combine in simple whole number ratios to form compound atoms which we are calling as molecules. Okay, this is one point. Another postulate is atom is the smallest unit of matter that takes part in chemical reactions. So atoms are the smallest particles which are taking part in the chemical reactions. So they are the important postulates from the Dalton's atomic theory. Dalton's atomic model became the basis of further research on the structure of the atom. So based upon these postulates which were proposed by Dalton, further scientists they have done research on this structure of atom. But but today Dalton's theory is almost discarded due to the discovery of subatomic particles and the discovery of another particles present inside the atom. So of course, the almost all the points from Dalton's postulates were discarded except one or two. Out of them, the point which you have seen here, atoms are the smallest particles of every matter which are taking part in the chemical reactions. It is being true till now, even now also. And atoms are participating in the chemical reactions is being true, except that almost remaining all postulates were discarded because of the new discoveries. Now let us see why it is failed. What are the defects or drawbacks in the Dalton's atomic model? Let us see one by one. First among them is atoms can be divided further into subatomic particles like electrons, protons, and neutrons. And not only this, and also other particles like mesons and positrons, etc. That means there are still smaller particles existing inside the atom. This proves that atoms are not the smallest particles. But John Dalton proposed that atoms are the smallest particles of every matter, and these particles are the ultimate particles of every matter. But here, later to Dalton, they have found certain particles existing inside the atom. Those particles are called as subatomic particles. Out of them, the important particles as we know are electrons, protons and neutrons. Along with these three important particles, there exist some other particles also, like mesons, positrons, etc. So these all are existing inside the atom. Now, atom is no more smaller particle, isn't it? So in that way, the first point from the Dalton's atomic theory was failed. It is discarded. Atoms are not the smallest. There are still smaller particles existing inside the atom. Another point is nuclear reactions show that atoms can be created and destroyed. Actually, in the Dalton's atomic theory, he proposed that atoms neither be created nor be destroyed. Atoms are the ultimate particles and they cannot be created nor be destroyed, he told there. But later on, they found certain nuclear reactions in which atoms are being created and being even destroyed also. Those reactions in which atoms are being created and destroyed are called nuclear reactions. The reactions in which two or more smaller atoms combine together to form larger and bigger atoms, or a bigger atom splits into two or more smaller atoms, are called nuclear reactions. In these reactions, if you see, this is the one reaction. One or two smaller atoms they combine together to form a bigger atom. This is one kind of nuclear reaction. In another kind of nuclear reactions, a bigger atom splits into two or more smaller atoms. So in this way, in nuclear reactions, atoms are being created and are being destroyed too. By this, the postulate which was proposed by John Dalton is discarded. That atoms are the ultimate particles. Atoms neither be created nor be destroyed. This point was discarded because of the discovery of these nuclear reactions. Okay, so in the nuclear reactions, atoms can be created or can be destroyed also. In this way, the second point was discarded. Next, discovery of isotopes proves that atoms of same element need not to be similar in all respects. So in one of the points from the Dalton's theory, it was told that atoms of an element are having all the properties same. Atoms of an element are having similar properties. But by the discovery of isotopes, this point was failed. So chlorine exists in two isotopic forms, for example. If it is chlorine, it exists in two isotopic forms. Isotopes means actually the atoms with the same atomic number but different mass numbers are said to be isotopes. For example, if you see chlorine, chlorine exists in two isotopic forms. They are chlorine 35 and chlorine 37. It means both are of the same element. These two atoms are from same element chlorine, but both are having one property different. That is mass number. Mass number of one chlorine is 35, whereas the mass number of another chlorine is 37. But both are of the atoms of the same element chlorine. But according to John Dalton's theory, atoms of an element should have all the properties same. But here, in the isotopes case, one property is being different, that is the mass number. Even though these two are of the same element, but they have one property different, that is mass number. This shows that atoms of the same element can be different in some respects. In this example, mass number of chlorine in the two isotopes is being different, isn't it? For one it is being 35, whereas for other one it is being 37. Of course, this is because of the difference in the number of neutrons existing in the nucleus. But anyhow, one property is being different. This is a controversy to the Dalton's proposal that atoms of an element have all the properties same. Okay, in this way, that property is discarded. That postulate. Another postulate is discarded by the discovery of isobars. The discovery of isobars proves that atoms of different elements need not to be different in all respects. Here, isobars means these are the atoms with a different atomic number but same mass number. Okay, atoms of different elements with different atomic numbers, but if they have same mass number, then they are called isobars. So actually, in Dalton's postulates, one of the postulate explains that atoms of different elements should have all the properties different. No property is going to be coincided for the atoms of different elements. But by the discovery of isobars, one property is being common for different elements also. That is mass number. Atoms with a different mass number, with different atomic numbers, but same mass number are said to be isobars. So the discovery of these isobars proves that atoms of different elements may also have certain properties same, need not to be different in all respects. For example, consider the atoms of argon and calcium. We know the mass numbers of argon and calcium are same, that is 40 for each, isn't it? This shows that atoms of different elements can have certain properties same. In this case, the mass numbers are same for these two different atoms, isn't it? Both the atoms are having different atomic numbers, but their mass numbers are same. So this is controversial to the proposal or postulate of Dalton that explains that atoms of different elements are different in all respects. But here they are being same in one aspect, that is mass number. So by this discovery of isobars, that postulate from the Dalton's atomic theory was discarded. Okay. Another point is discovery of polymers and macromolecules proves that atoms can be in large numbers. Atoms can combine in large numbers. But in the postulates of Dalton's theory, we have observed that he proposed that atoms of same element or different elements, they combine in simple whole number ratios to form molecules or compound atoms. But here he told that only small number of atoms they combine to form molecules. But later to him, scientists they have discovered polymers. A polymer is a large chain-like molecule made up of small molecules. So in the formation of a polymer, so many atoms they combine together. Even sometimes hundreds of molecules also they combine together to form a big molecule called polymer. In this way, for example, we know polyethylene. Polyethylene is a polymer which is made from simple molecules, ethylene molecules. So these are simple molecules, so many they combine together to form a big long chain molecule called polyethylene. In this way, by the discovery of these polymers, that proposal or postulate in the Dalton's atomic theory, which tells that atoms combine only in the simple whole numbers to form molecules, is discarded because in the formation of polymers, atoms are combining in the large number. They form a chain-like structure with so many number of atoms together to form a bigger molecule called polymer. So in that way, that point is also discarded. Okay, that's about the Dalton's atomic theory postulates and the drawbacks or defects of this theory. So even though these all points are discarded, but still one point is being followed, that is atoms are the smallest particles of every matter which are participating in the chemical reactions. This is true even now too, isn't it? In the chemical reactions, atoms are only participating in the chemical reactions. They're only rearranging to form new compounds and new substances. That's being true even now also. Except that remaining all points are discarded from the Dalton's atomic theory by the new discoveries. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded videos.